it calculated the area and the volume, and the sketches on the left and the right are both sketches of the final robot.
Yeah.
So yeah.
And you can calculate where the center of gravity is and all.
Yeah. So if we go back to the last slide, it has everything here. Like center of gravity.
Yeah, on the far right.
On the far right, on the bottom, it says the center of gravity down here.
Center of gravity of individual pieces, and then the software builds up the center of gravity of the whole machine. Am I right?
Yeah. So then this is our evolved. This is our evolved robot. Now we're getting into like making the actual robot on CAD software. We made this on CAD software called Autodesk Fusion 360. So here you could actually see like the claw and the drawer slides, and you could see the motors a little bit. Yeah, you can see the motors.
Yeah, the GC motors are like those yellow things that you see on the bottom, and you can see like how the
point it to that way.
Yeah.
yeah.
So what is this unique mechanism? Can you don't have animation.
What?
We don't have animation.
Oh yeah, we don't have animation yet. Yeah, we need to simulate it. We need to simulate it. So basically, once you build the robot, you have to simulate it through using force and stuff.
You're not done it yet.
Yeah, we haven't done it yet. So, do you have any questions right now?
Explain him the vertical lift.
No, go ahead. Go to the next one.
Go to the next one.
Yeah, that's fine. That's fine.
So this is our evolved. So this is our evolved. This is our evolved robot on CAD. So this one was created on Inventor Professional, Autodesk Inventor Professional 2018. So here you could see
Move the cursor.
here you could see the drawer slides, which is used to, and you could see the claw here, and you could see the motors and everything. So do you have any questions right now? You know.
Okay.
And the bottom is it shows the actual drivetrain and chassis, and it shows the 4 wheels.
Yeah, remember we showed you like the 4 wheels earlier. We put them on the inside instead of the outside.
And what are these black things on the left hand side? These 4 black.
Oh, the 4. Oh, these are the servo motors. This. Yeah, these are the servo motors.
That's what?
What?
Yeah. Go to the left one on the top.
Yeah. This one?
Yeah, so that servo is connected to a small gripper.
Oh, to travel.
So
point that to them.
Yeah.
So this servo here,
Travel.
this is connected to the servo is connected to the small gripper that actually grips the cubes. So these two right here, this one and this one, they're used for gripping one cube, and then this one and this one, those are used for gripping another cube. So together they could grip 2 cubes.
And show the rotation.
And then this DC motor here, this is used to rotate the whole thing. So it rotates the whole claw, and these drawer slides are used for lifting it up and down. So
Up and down.
yeah.
Okay. Good.
Come on. Alright, so this is our final robot, like when our robot's actually built. So as you can see, it's similar to the CAD design, and we also added the electronics. So as you can see, there's a lot of wires and everything. And yeah. So
Yeah.
this is just a team picture at an event we were at, and the robot's over here. So do you have any questions right now?
Did you get where is the software? You did it, or it comes with the some commands come with the
With the software, yeah,
controller and
the you have to basically, yes.
So they basically they give you all the packages and all that, and all the methods and all.
Framework.
And
commands are given and you put them together.
yeah, so they give the framework and you just put them together.
Am I right?
Yes, correct.
And update as you need, right? Based on your design, you need to update.
Yeah,
This is where
Kevin
the
doesn't have
photo
a
of you guys at the
event.
what do you call that competition.
Yeah,
Yeah.
yeah.
And now you're first in your zone, right?
Yeah, almost. Almost.
Pardon?
Almost. We're almost first. Yeah.
Good.
So.
Okay. You
Yeah.
have any more questions?
So,
How many motors do you have now? 4 for
Uh,
the main wheels, 1 for the going up and down. How many motors in all do you have?
yeah, so we have 4 motors for the wheels.
You already asked those questions.
2 motor. We have 4 motors. Huh?
4 motors for
Four-
the main base.
4 motors for the base. Ideally, so on this competition, we had 1 motor to do the whole lift, but we want to have 2 motors now, 1 on each side. And then we have 1 motor for the rotation of the claw,
Of the what?
of the claw, of the claw, of the gripper.
Okay.
And then we have 4 servo motors, which is a different type of motor for the grippers in the claw.
For what in the claw?
The grippers. So the claw, it looks like this, right? So it needs to close like this. So we have 4 motors to do that because we need 4 arms.
Yeah. Now let me again understand. 4 motors on the 4 wheels which touch the ground.
Yeah.
Then 1 motor for up and down motion. Is that what you are telling me?
Yes.
Yeah.
Huh?
Yes.
Yeah.
1 motor or 2 motors? 2 motors or 1 motor?
Right now we have 1 motor, but we're thinking of making it 2 motors so it's more smooth.
To lift the whole thing up and down.
Yeah.
Yes.
Yeah.
Okay. With 1 motor, how are you lifting it up and down?
So with
So we had a rod going through the middle of the robot, and then we use the sprocket and chain system to so that once you run 1 motor, the rod spins as well and lifts the other side as well
Axle.
over an axle.
Just 1 second. You have the whole thing moving up and down on a rod, right? Vertical rod.
We have it on a drawer slide.
Huh?
A slide, a linear slide.
Yeah. Now, ball slide or normal slide?
Yeah. So it's a linear slide.
Okay. Now, only 1 slide is there.
There's 2
2
slides, one on
slides.
either side of the robot.
And how many motors? 1 motor to drive it up and down.
Yes.
Correct?
Yes.
Yes or no?
Yes.
Okay. Now you want to put 2 motors.
Yes.
Now, both the motors don't run at the same speed, you will get into trouble.
Yes.
Yes,
Yeah,
correct. So the programmer has to make sure that the motor powers are the same on both of them.
Motor?
The speed,
Motor?
Motor what?
the speed of the motor has to be on the speed of the motor has to be
Both sides?
the same.
Yeah, identical.
Yeah.
Speed has to be identical.
Yeah.
This side.
Yep.
So that is something you have to work out. You have to worry about.
Yeah. Correct.
Usually, yeah. Okay?
Yep.
Yeah.
So, then why are you shifting to that? You just think
Still, there is
this
an
versus that. Because, you know, you have a table drawer, right?
Yes.
Maybe you have some drawers.
Yes.
If you tilt the drawer slightly and pull, it will jam.
Yes.
The same thing will happen. If you don't pull uniformly both the chains, it will jam.
Correct. So, do you know if each motor has an error? Do you think it's possible to run with 2 motors, or do you think there will definitely be an error and it'll cause it to jam?
You must be lucky. Sometimes it will work, sometimes it won't.
Oh.
At the time when you want it, something will jam.
Okay. Okay.
You try it and then discard it.
Okay.
You have to also know that things jam, right?
Yeah.
If you want it to be a learning exercise,
Sandeep's
make
brother
it.
is a mechanical
See,
engineer.
Correct.
Can't run it by him.
you
Yes.
That's something you have to do.
Okay. Uh-huh.
Mhm.
Then what else?
Yeah, so that's it. Do you guys want to talk about Autodesk Fusion?
Oh yeah. So basically.
What are the three CAD softwares?
Basically, the three CAD software, the three main CAD softwares we use to actually build the robot is PTC Creo, Autodesk Fusion 360, and Inventor Pro 2018. So each CAD software has its pros and its cons. So for example, Fusion 360 can't cut parts that easily. So we've been basically moving from one software to another to see, because we've been finding more helpful, more easier to use softwares. So these three designs were built on PTC Creo. These the three designs you see on the screen. These two were also built on Creo, PTC Creo. And this was built on Fusion 360, and these two were built on Inventor Professional 2018. So
The kit you are using is from which company?
the parts we get this from is from a company called Tetrix.
And they're sponsored by the FTC competition.
Yeah, so Tetrix. That's what
I
it's
was
called.
seeing there were similar parts from Fisher Price and from Lego. So I was just curious to know where you got this from.
Yeah.
That's good.
Um.
So, what are the restrictions they put on you when you want to build this? Did they say you shouldn't do this, you should not do this? Is there any restrictions?
So basically, we have to use a certain amount of motors, and we can't have any like sharp things on our robot, and we're not allowed to put anything on the robot that could destroy other robots, like a harpoon or something.
And also
You
the
can kill other robots.
yeah. The main restriction is that it has to be within 18 inches by 18 inches by 18 inches.
That is, the whole thing must be within that size.
Yes. Yeah.
And we nearly got disqualified from our meet because our robot almost didn't fit.
I think, what?
Wait, what?
You were saying that I was hoping that you would bring the robot.
Yeah, so we weren't able to bring the robot because right now it's all loose and stuff because we're adjusting the robot for the next competition. It's coming up in a few weeks.
We can. Video that was
So, you could refit the whole thing back from the given time, right?
Yeah, no. So we'll actually call
This one. Yeah, tell me.
we'll actually call you another day once the whole final robot is built again, so you could take a look. I think we sent you a video of our last robot, so if you could take a look at that as well. Yeah.
I saw the previous video, but I was wondering, so why were things loose? Was it because you didn't tighten them properly, or you didn't complete what you wanted to do?
So during the competition, the thing was loose because the company we bought the pieces from, their parts are generally not the best. So all teams whoever use those parts, the screws come loose because they're not the best quality of screws.
There was no way you could tighten them?
Yeah, so we tightened them after every match so that they weren't coming loose. But now we took the robot apart to fix some stuff. So that's why we couldn't bring it in to you today.
Okay. And do you know how to keep a screw from while you...
No. We just put nuts on them, but the nuts came off.
Yeah,